respond back to the students. So if you have your notes, if you have your materials, this can be enabled as a very simple application in the lab or for the students to use, and students can effectively use them for any of their learning purposes. So rather than for them to rely on something like ChatGPT and getting into the habit, you will be forced into the habit of copying, right? You cannot avoid that, and it's very, very tough because of the way the brain works. There is a concept called as instant gratification, right? Your brains are very much addicted to it. You don't want to postpone the benefits or the good things that you get later. Rather, you want to immediately get them because that is what you see. That is basically what is called as instant gratification, and that is also psychologically proven. So that is also psychologically proven, and delayed gratification is always what has got you the best of the results. But in today's world, that is not actually happening. So when you have an application like ChatGPT, right, and if it is giving you instant answers, your brain actually gets hooked to it without you knowing it. So the next time you have an answer, the brain always tries to figure out the ways to do the things in the easiest possible manner. The brain is tuned to that. That is how. That is why we are able to survive. If the brain always would have taken the toughest path, our survival itself today will have become a very big question mark. So that is why now we are not going to restaurants. We are not traveling by auto. We are just using the app, and it immediately comes. It is very hard for us to break that habit, and we are not to be blamed. People have psychologically tapped into the human behavioral patterns and access. These apps today, it's not just technology. It is a lot of research around human psychology, human behavior that has gone into the making and the development of applications like this to influence you, to keep you hooked. They use the word hooked in social media. Facebook, they want to keep you hooked. Instagram, Reels, 15 minutes, 10 minutes. Now, no one has got the patience to watch a 5-day test match. That came down to 50-over match. Now no one has got the patience to watch a 50-over match. Now 2020. Later 10-over match will come. Now no one has got the patience to watch a 3-hour movie. Short films have come. Now even the 3-hour movie, watching those shorts, reels, the entire movie is done. Fine, we go away in half an hour. We could say that, no, I've saved half an hour and all of that. But that is not a very sustainable way of looking at things. You tend to skip the details. You don't allow yourself to go through that experience. Quantity has become more pronounced in today's world rather than quality. One good quality book, no one really wants to bother. Rather, they want to take 5-10 books, some from here, some from here, some from there, put it together and just give it out. That is how the trend has been, and that is how we have been influenced to do, unintentionally and unknowingly. So getting to understand and realize that, and separating ourselves and surgically leveraging it to your advantage is what we should do, rather than getting addicted to it. And addiction does not necessarily has to come from drugs, right? Addiction also can come from sugar. Addiction can also come from media, especially in digital platform. The effect on the brain is much more pronounced than that of the drugs. When you're taking a drug where you can get addicted, it is not easy. The first 3 to 4 times is very, very difficult. You will struggle like hell. Then only your brain starts to adapt. That, okay, I'll adapt to it, I'll take the right to enjoy the benefits of it. Because your brain does, you does. It's not the other way around. The initial prompt is what you are not able to take because the brain adapted. But media is not like that. You take YouTube shorts. Why did they create all these shorts and reels in the first place? For one reel, I think the digital marketing people today are earning almost 80,000, 70,000. That is because so much of people are getting hooked to it. Next, brain gets hooked. Like what we blame our kids for playing video games or watching cartoons. Even us adults are not able to come out of that. Us watching reels, shorts, everything. It's also the same behavior. End of the day, the source of the content can be the different, but the impact, it has got the same effect on the brain. So realizing that is, I think, is very, very important. Okay. Now, coming back to Rag here. How context transforms. So I think we have talked a lot about how questions are connected with chapters and how we get the information. So I will skip all that. Now, whenever you know the source of information from where you are answering, you are always bound to cite it with confidence. Today, giving citation and giving credibility for the source from where we are getting inspired to take the content itself is become a very big challenge. People are not citing it for whatever reasons that is being followed, right? Thinking that not citing something will give you originality. That's not the case, right? There are a lot of first of all, you defy your own principles, and you're giving something to the community or the society around you, which further gets consumed for a different purpose. Now, only if that is original, it will have a very positive impact, and that is where people from academics and researchers has got a very large role to play. But if that is not getting created, then it gets diluted and polluted over a period of time. The impacts are very, very adverse, in my honest opinion. Okay, so that is how. So when you know the source, you can always cite, and because the RAG has got a way from where it to retrieve the source to answer the question, citation becomes inherently possible. Using some metadata, using some pointers, using some if I say that I am taking the answer for this particular question from row number 10, I will know that it is row number 10 from this particular document, and I will cite it. So now, is the citation correct or not? That is where reviewers, moderators, and validators would come in and tell you that is a better citation than what you have taken. Now that goes into the making of a system, or that goes into the thinking process of the student to come out with better answers. Or if it is wrong, you would say, no, this is not the right citation, though this mean solution A, but there's another better solution that you'll have to approach for the same problem, right? So the way to ask the questions and to reason it out and to try to figure out the answer is where I think the learning actually goes into it. Something like this, whatever PDF it is, page 15, paragraph 3. Now this is how we improve the way we respond to user questions. So citation has got document tracking, trying to find the right document, source matching, and matching the question with the appropriate source, and verification. If we bring that the source and put it so that some validators can verify it. Okay.
Yes, waiting in the lobby. Yes.
Oh.
I wait more time, so they are waiting to join.
I don't think. Sorry, what more?
No. Because they are after the hybrid or online.
Okay, but here I don't see.
Students who are online, please proceed.
Okay. So I've also given some use cases which you can probably discuss. As an activity, what you can probably do is, rather than trying to think too much around technology, rather than thinking too much around technology, the main idea is to give you the perspective and to come sit together and try to create a process or a document in terms of how this technology can be leveraged. And that is why I've given you some use cases here, how it can possibly benefit, and what are the hypotheses you can possibly generate. So if you say that, for my subject or for my undertaking of a particular initiative, I need all these things, and I need and you define it better. You create a requirement. Now, once you understand the requirement, now that you know what generative AI does, what RAG does, how it works in the backend, that is all it would take for you to write something on paper, or at least draw something on paper, sketch something on paper that has your initial plan. Once that plan comes in, it does not have to be a perfect plan, but some plan to get you started. Now, once you have that plan, someone like me can collaborate with you, try to get that into a working model as a draft version, and then we can probably do some iterations, add more documents into it, and try to create a small prototype or a MVP which can extensively be used by your entire institution community here, and set an initial stage for the rest of the people to contribute more, either to the application or to be inspired by your application and create something new. What you might have created would be for something like a text. Someone says, no, I have a use case where there are a lot of posters and images and diagrams which I want to consume, and not just NLP. he might be inspired in the way that you have done. The same framework will be followed, but with some nuances. The model will be able to understand the images and the pictures rather than the text, but your same framework would be used at a larger scale. Now that is how the things can start to get rolling from an ideation perspective, right? The expectation here, the reason why I did not go into technology, coding, this and that, because that is not what that can today's machines are able to do it. If I'm asking ChatGPT to create a RAG application with all my requirements, right? It would give me the code. If you're asking the students, hey, you're good in Python, come just research on this, develop on all this, and you give them the documentation, 1 week they should be able to do it as a very small prototype. But who is going to give them the idea? Who is going to give them the directions? Who is going to tell them what to do, what not to do? Who is going to give them the use case? Who is going to give them that these are the documents which you should use, these are the documents which you should not use? That even ChatGPT today will not be able to do. It can only give you a generic template. The actual ideation, the actual thought process, the actual reasoning, the actual decision making, the actual definition of something is in the hands of faculties and researchers like you here, who can drive those initiatives and to implement. Like I said, n number of people are there to do the implementation. Technology itself is there to do the implementation, but the idea origination is the technology today has really not mastered it. It can give you suggestions. If you're asking any better way, it can give you X options, Y options, but ultimately that source of that one idea head who is to drive all of this is where I think potentially you would step in. And that is why we have been talking about a lot of concepts and frameworks and process which can help you at least connect different pieces. And again, for one person to do all of this is practically impossible. And in this 4 hours, if you're asking one of you to come step forward and do end to end, that is not realistically possible. But in the entire 4 hours, a few of you would have got grasp of some concept. Few of you would have understood some other concept. Now, when you come together, when the brainstorming happens, when the ideation collides, right? That is where that like a Big Bang theory, something new comes out. And it does not, like I said, it does not have to be perfect in the first position. It can be something like a seed that is sprouting with more curation and with more taking care of your ideas and use cases that can evolve into a very good application today, right? At an academic level, using with all open source technologies, operating at a very cost, you can easily build good MVPs to actually understand the power of the technology and then extend this technology into something which you can use from an application perspective. Okay, I think these are, first you need the ideations, and then you need the context and the approvals that has to come in, and then you implement it to understand the power of this technology from a more pragmatic or a practical perspective, and then you roll it out to other applications, like whatever task that you want to do. Now there is a misconception or misunderstanding that if we are to do the ideation, then do we also have to really need coding or the framework? Even in IT, right, even in tech industry, this is how it works, where you have some person who understands technology as a whole, who understands the ethics as a whole, who understands the frameworks, the concepts, what is possible with this technology, what is not possible, and then he would be there. He would then transfer that vision or transfer that idea to his subordinates, who will be his leads. So let's assume the manager is having the idea, he transfers the vision to his leads. Now his leads would go create a plan, create a structure, and then go to the engineers, use the engineers to do the work, validate with the leads, and the leads will in turn come to the manager, because the manager is responsible for the vision, managers are responsible for the strategy. Manager knows this product today, 10 years later how it will look, managers will know. Leads, that is a vision. Leads know how to execute that one particular piece of requirement that has come from the manager, which is basically the mission. And to execute the mission, you need your engineers or the people who can actually get that mission completed. So that is how even in companies like Google, Microsoft, Apple, it works. Not everybody is expected to do everything. Rather, one person is expected to specialize in his roles and responsibilities. at whatever background that he comes in from, whatever expertise that he comes from, right? He was saying that the manager can be someone wherein it says, it is required, it is able to get the references, all right, but there are also other sources which you can include. So today I can include 4 5 books, but that expert there, as the manager, would know what other expert materials can be used to better answer this question. So now the lead will go collect those resources, include it as part of the bookshelf or the repository, and the engineers would develop or fine tune it in a way that it is able to better go to the best resources that was newly brought in, and not really use any outdated information that was already sitting in the corpus or the bookshelf that you want to access. This is how things has to get rolling to build even a very simple application. It is simple, right? But it is not easy. You need to understand that difference, and you should never underestimate anything. It is very simple to implement with a lot of technology sources, everything, but it is not easy. So that is where the distinction comes in, and that is where your role will be very, very predominant and pivotal in getting something like that to be alive. Today, it can be very simple, etc., etc. But for your document, when you are asking a question, if it is able to get that from your notes, you will then start to have a different perspective altogether. So that is why whenever you are starting something, don't start something to be very big. You will definitely have your notes. Use that notes first. You will know some 10 20 questions that the notes can answer. You take those 10 20 questions, build a very simple HTML web template, use some open source models, ask the models the question, see if it is able to get the right section of your notes, and it is able to respond. Now, because you have prepared the notes, you will be in a better position to validate the responses. How accurate is it? It is able to bring. Now, when you see just that piece of work, your entire thought process and perspective towards this technology will change. And just focus on this and become an expert in this. Basically, generative AI, prompt engineering, and RAG. Start with very simple notes and then extend it to textbooks, research papers, website. It goes on. Just focusing on this will really make you a niche for maybe 10 years or even 20 years to come. This will not go away at all. Especially for us, technology may evolve, technology will grow, right? That, no doubt in that. But for you, for us to be in a place like Tamil Nadu, working in a college or working in academics, basically, or research, this will be there for the next 10 to 20 years solid. And once you have mastered it, or once you can talk about it, and once you can empower more people to do it, you will find your own niche in your industry. That is 100% guaranteed. Just that this somewhere it has to happen, but that initiation, once it happens, and you spending a lot of time on it every day, half an hour, 1 hour, and 1 week, 2 hours, 3 hours, working with like-minded people, working with students continuously, iterating on it. Failures will come. You should not get dejected or demotivated. Just try to keep up your motivation. Try to bring something, and that something over a period of time will become that one thing which will take you into your career 20 years solid. Because even in industry, in a commercial scale, RAG is very, very so powerful, and people are spending a lot to build applications, and that is bound to live for a very long time. At least for the next decade, this technique, all the things that we've discussed, will hold good. Once, even if you know some 10 20% start with it, you will have you'll maybe become top 5% of instructors or researchers in the entire academics research list that you can source out of Tamil Nadu or even from India. Even when I interact with professors from IISc, IIScr, or IITs, they understand. Not everyone understands RAG today. People from chemical engineering are still yet to figure out how this works. So what they do, they go sit with computer science professors, IT professors, students, interact with them. Now these chemical researchers and instructors have a very strong domain knowledge. That domain knowledge is very unique. Technology is very common. Domain knowledge is not open source. Domain knowledge, lot of things goes into it. That is where your specialty is. Technology is open source, everything else is open source. So these people interact with computer scientists, researchers, and other faculties, work with the students, and try to build some generative AI application based on some of their requirements, which they see as a problem statement that can be solved. And it does not always necessarily have to be a problem statement. It can be a simple fun challenge. It can be something for you to explore, for you to pragmatically understand how it works functionally. So when you see this application, you should be able to verify. Okay, I ask a question, it is going and hitting my folder. From the folder, it is trying to fetch the right document. From the right document, it is able to get the right passage. Now for this question, it is able to connect with the passage, use that as a reference, and it is able to answer this. If this visualization, if you're able to practically do along with a team, you will see a very profound impact in terms of the change that it can bring to your own academic professional journey, and also in terms of how you can empower the research community and the academic community around you, inclusive of students and co faculty members. Okay. So this is what RAG is. I think we've extensively talked about. But I have also broken this down in very simple terms. So you have your documents. You break those documents into pieces, which is a chapter can be broken down into passages. Passages can be broken down into sentences. Sentences can be broken down to phrases. Phrases can be broken down to words. Words can be broken down to characters. Whatever level you want to break it down, you can break it down. So that depends on your use case, anything, right? If you have a 5-page notes, you can break it down into 1 page or half a page or quarter a page or line by line. That depends. So you can control that, how you want to organize this information. Why I'm bringing this point? Like I said, only when your retrieval strategy, retrieval of information strategy, information should resonate with how you have stored the information. Only when you know that in a library you have organized the books in this manner, for you to pick a book will become very easier. But when you are not clear in terms of how you have arranged the books or organized the books, for you to get one book itself will be a very big challenge. So how you want to break it out and organize your information is very, very important, so that your retrieval becomes very efficient, optimized, and accurate and relevant. Okay. So storage and retrieval always goes hand in hand, and you cannot break them. And understanding the meaning of it. AI reads and gets the information and meaning, finds the best matches like Google, but in a very smarter manner, and then writes the answer with appropriate citations and references, so that you know what you have answered and from where you have answered, which is very, very important in academic and research area. So why this matters for faculty, I think I've given multi-stage retrieval. Those are like advanced, but still at least getting to know the words, the trigger words, the technology association, how these are conceptualized, that itself solves most of your gap today in getting closer to this technology. Okay. So this is one part of it. It's already 11:20. I'll quickly move to the architecture. Now we've seen the concepts. You don't have to necessarily... It does not come here. Okay, 1 second. Okay. So I'll just focus on one specific part of it. How does the matching happen? Because whenever you are interacting or operating with machines, it is always numbers. If you are giving a text, text has to be converted to a number. If you are giving an image, image has to be converted to a number. If you are giving audio, audio to a number. Video, video to a number. And number is same as the number. End of the day, it has to boil down to number. Number to bits, let us not go into that. But every information has to be numerical information. Why numerical information? Only with numerical information, computation can happen. And all our development around building of laptops, computers, processors has been centered around mathematical models. In mathematical models, we use expressions, we use evaluations, and we use numbers to do it. And maybe a text or a theorem to explain it. But you don't actually use text for doing any sort of a computation. So that is why it becomes essence for us to convert any information to a numerical representation. Now, if I'm asking, when you are asking a question, right, how does the machine know that you are asking this question, right? It has to be converted to a number, and that process is basically called as embedding. Okay, embed. Now, what is this embedding? It's a very simple term. It is an array of numbers. Array of numbers. That is, hi, my name is Raj Arun. Can be converted. Hi can be converted to some number. So my some number. name some number, is some number, Rajaram to some number, and that number will hold good. Wherever my is used across the machine, it will have the same number. That is how these models are trained. Whatever information that I give, end of the day, it is converted to a number, and that number is what is used to do the processing, calculation, probabilistic estimation, etc., to give you basically the output. And this process is basically called as embedding. Embedding is what you have a text. The text gets converted to a stream of numbers which the machine can understand. Now, is the stream of number any random stream of number? No. It is a stream of number with semantic meaning associated with it. What is semantic meaning? If I'm taking the word bank, bank in a geography textbook can be like a river bank. A bank in a financial textbook can be a financial institution where you can deposit money, or in a medical context it can be a blood bank or an organ donation bank, whatever. The bank itself has got different meanings, right? So when this bank goes along with the medical context, it will have a different number. When the bank word goes along with the financial context, it will have a different number. When the bank word goes with something else, it will have a different number. That is what is called a semantic association of a particular word. Without semantics, that inherent way of understanding a particular text will not be there. And for you to know that, embedding helps us achieve this. So tomorrow, when they say that, I'm saying something, how is the machine able to understand? You would say the machine is able to understand because it converts the text into a stream of numbers, and this stream of numbers has some meaning associated with it, and that in this particular technology, it is called as an embedding. That is all. You don't really have to know how it is done, why it is done. No, you just have to know how. That is, when I say this, what is happening, that understanding is more than sufficient. Now, using this embedding, what can I do, right? Now, if you have two numbers, say 10 and 20, now what is the difference between the two? You will say between 10 and 20, there are 10 units that separates them apart. Now, between 10 and 5, there are 5 units that separates it apart. Now, 0 and minus 5, there are 5 units, but in a negative direction that separates it apart. So just giving two numbers, you can try to figure out how close they are and how far away they are. So if you have two vectors, right, using these vectors, which is basically a n dimension string of numbers, you can when two vectors are given, based on their plotting in a graph, you will know how close they are and how far away they are. Now, when you're asking a question, that question gets converted to a vector. Vector is basically this embedding. So your question has a vector. Now you have your documents in your bookshelf or in your folder. Now these documents also would be vectorized, and there are some techniques that goes into it, but don't worry about that. Just know that your question is also vectorized. All your documents are also vectorized. Now what I will do a search for my question vector. Which document vector is close? And the document vector, that is why I said breaking of your information is very important. The document vector can be your chapter vector, the document vector can be your passage vector, the document vector can be a phrase vector. You will have to decide. Once you tell your implementation people that you break this entire chapter into passages and you go and vectorize the passage, because when you take a chapter, it is so huge. But for you to answer a question, you might not need an entire chapter. You might need a page, or you might need just one paragraph or something like that, right? So you give the strategy to them. Now you have a vector for your question, and you also have a vector for the page or the book or the chapter or the paragraph. Now I will do a search, a query process. Now for whichever this query vector, whichever vector I am getting from the document store or documents, whichever is close, I will know whatever document I use to create that key vector, right, for the document is the content that I am looking at. So my question got converted to a vector and it stops there. Okay, it stops there. Now I have list of documents. For simplicity, I will give the documents in the form of paragraphs. Okay, or the entire chapter book was split into para 1, para 2, para 3, and I have one txt file or one doc file for every paragraph, and I keep it there. Now what I will do, similar to how a question is getting converted to a vector, each paragraph document that you created or each text file that you created for each of the paragraph will have a corresponding vector associated to it. like how you have serial numbers in your Excel sheet, something like that. Okay. Now, when I am doing a comparison, the vector that was generated for my question gets compared with the vector that I generated for all my passages. I will do a search and I will retrieve what two vectors are very close to my question. Then for each of these vectors, you know what paragraph was used to generate the vector. So what you will do using this search, whenever there is a hit, you will retrieve that passage. And there are techniques which is used, which is very simple. You retrieve that passage. Now your question is there was a vector. You use and brought the content. Now you have a question and you also have the content. Now this you will send it to the model. Now all this process does not really require any modeling. The vector generation, the search process, it is a different step altogether, which will not require any modeling. Now, once you know the content based on which you need to answer, along with the question, you create a template. I said, no, template. What is the template? You will have a question, your question will go and fit in, like an HTML page. You will then have a context, the passage that you retrieved based on your vector search will go and fit it. And in the output, it will be an empty passage. Now, you submit it to the model. Now the model will take the question, take the context, answer, put it response in that output tag or the output section. Now that comes out. Now I will have to write the code to extract that output from the response and present it to the user. This is exactly what happens, and this is the advantage that you get whenever you are converting any content to numerical information. Now is this only applicable for text? No. If you have an image also can be converted to a vector. So if you're doing a Google search or something, you give one image of something and you want to retrieve similar images. So what you do, you have some 100, 1,000, 2,000 images. Every image got converted to a vector as part of some process, but it got converted to a vector, and that information is stored in your store. I will call it as a document store. In your document store, you have your image and the corresponding vector. Okay, that is there. Now, when you are submitting, what happens? Your image gets submitted. When you are submitting an image, I will not directly send it to the model. I will take the image, also convert that image to a vector using the same process. There I am using a different process. Here, if I am using a different process, there will be mismatch. It will lead to total chaos. Instead, I take this image, convert it into a vector using the same process that I used to index all my images. I will do a vector search, retrieve all the images, maybe top 5 images or top 3 images, and then I will present it to the user. Here LLM is not even needed. Generative AI is not even needed. It is a simple image search application that you have developed as we speak. Just by using vector and vector similarity. Which vector is similar? If vector is similar, content is also similar. So retrieve the content. That is how the retrieval process actually works. Now in the image process, we never talked about LLM. There was no need for LLM at all. Just images. I want to retrieve images. This is what you do. You have a image search engine ready for you. Using this image, if you want to generate some content, if you want to do some analysis by the system itself, then you have your query image that you submitted and the retrieved image, and then put them together, create a template, put some prompt to question or put some questions, how many cars are there, how many books are there, or what is that formula like to the LLM, and the LLM will be able to absorb the query information and the search images information, try to generate a response based on the prompt that you have submitted, and using that prompt, it will be able to give you a synthesized answer. So if it is only retrieval of content, be it text, be it image, be it audio, be it video, you don't need LLM or generative AI. But if you want to do some analysis, if you want to synthesize that information to generate some content which will give you some insights, then LLM is required. So whether LLM is needed or not is the first question that you need to ask for your particular use case. If LLM is needed, how do I use it and integrate it with the rest of the techniques to give you it basically does synthesis. If you want to synthesis your output, if you want to analyze your output or input, or if you want to assess your input and generate some responses, that is when or where you will bring LLM. The rest can be achieved using a standard query process, search and query. In database, you can directly query. Here you are using a query using a vector, and there are certain techniques to use it. But fundamentally, the concept is that. And if you are asking me, okay, now we know that there is a query vector, there is a search vector. Using query and search, I will retrieve the information. That is the underlying concept. What programming languages are used, what tools are used, there are hundreds of ways by which this can be achieved. That is why implementation, there is no roadblock. Implementation is very accessible. 1,000 people will do 1,000 different types of implementation. But the initial ideation in terms of how should the doc store be created, what content should be stored, what content should not be stored. If you store the image, is the image having a good quality? If the image quality is not there, as a human validator, as a reviewer, you should remove those images so that it does not reduce the quality of your output generation. What questions you should allow the user to ask, what images you should allow the user to upload, what mechanism do we have to filter that, to review that and moderate that. For fun, we cannot upload anything and everything, and we cannot control that as well. So how do we create that structure? This is how you need to create lots of layers and elements in terms of how you need to create an application. Now once that plan is ready, with more help and contribution coming in from the different stakeholders, you can actually build a very small MVP where all these things can really be built in an appreciable manner. Okay. So I think understanding embedding was very crucial, and that is what this talk was all about. Further, what embedding is and how to convert it to math, the information is pretty much given here. For example, a text like this, when I say that embedding it as a vector, it gets converted to something like this. Array or stream of numbers, and this entire stream can be compared with another stream as a whole, like how you were able to compare 5 with 10 and 0 with -5. This entire stream can be compared with another stream of numbers 1 to 1, and this is how this stream of numbers would basically look like. And the closeness, right, whatever that we were talking, that is basically called as semantic similarity. Okay, semantic similarity, how close it is, how far it is it 99% smaller, similar, or 87%? All these can be basically measured. So now we are talking about embedding. So back in those days, how did they do? They were using just keyword matches. If I have 5 words, if same 5 words are there in another text, I will retrieve it. But keyword matching alone is not going to be helpful because of the example that I give you, because bank in a medical context can be different bank, blood bank, organ donation bank, etc. In geography, it can be different. In a financial institution, it can be different. Here, if I'm just doing a keyword search, for a medical question, I can retrieve a document from a financial corpus. That will lead to a lot of ambiguity in the answers, right? So semantic meaning, semantic searching has proved to be very, very effective right now, and that is why that embedding, concept of embedding is all that it should resonate. If that embedding word comes, the rest of all that we talked is inherently understood, which is converting text to a stream of numbers, which is basically a vector, and that vector carries some semantic or contextual information along with it. And when I say embedding, all these becomes inherently understood. Okay. If you have to search as well, if you use the word embedding in Google search, you will get all the relevant information. If you take other words to search, you will get only bits and pieces, and you will have to put in a lot of effort to collect them and put them together.
Math usually different places means they will use same meaning.
Can you please repeat it? Bank. So bank, if you use in medical context,
bank means storage area, storage device like that.
Like it can mean like that.
How it will differ from different areas.
Yeah. So if I want to again search for that bank in a financial context, for there the bank means a completely different paradigm altogether, where it is most of a financial transaction that happens. Or savings, etc., etc. Here it is most of storage that is associated with human biology. And if you are going to geography, it is river bank. That is a completely different context altogether. So if I'm asking a question from geography, I need answers from geography. I don't want answers from medicine, or I don't want answers from anywhere else. So if I'm doing a keyword search, I will not be able to differentiate bank in different contexts. But if I'm able to create an embedding which has absorbed the meaning of that background, of geography, medicine, etc., my answers will better be connected to the questions that I am looking for. That is the difference. And I've given the complete RAG process here, which is user input processing and how it works and all of that. I'll just leave it for your reading the moment I share with you. So most of what we've discussed is what it would be resonated here, but I've just given it more visuals so that cognitively it is easier for you to pick up all of this. I'm just going through it to see if there is something new that I'll have to probably pick from here. I think, yeah. So I think we can close this and move on to the next one, the last one is AI ethics. I'll just spend some 10 to 15 minutes. I'll spend some 5 minutes here because I at least want to introduce the concepts of AI agents. But the moment you have it, there's some problem to load. Okay, the content is comprehensive, but I'll just touch a few places because we've already talked a lot, gone through a lot. So today, when you are using ChatGPT, the moment you are asking a question, it gives you a response, right? And is that response right or wrong? That is the entire discussion that we have been having. Now, a new concept has emerged, which is called as agents. Okay. Now, agents is a framework that has been devised to give you answers in a different way. What is the different way? I'll give you an example. The moment I ask a question to an agent, right, what it would do, it would first plan the list of activities that it has to execute to answer back. For example, if I'm asking, what does it, how long does it take for me to go from I come from Sholingnallur, from here to Sholingnallur, rather than saying, if you're asking ChatGPT, if it knows the information, it will say on a peak day it will take this many hours, on a normal day it will take you this many hours, and it probably might give me that answer. But if you're giving this to an agent, the agent would get into the details like at this part of the time, what is the traffic like? Is it going to rain? And then is there going to be any public ceremony or public meetings outside? Whatever factors that could affect my travel, all that it would first plan out. Okay, these are the 10 different things I need to work out before going to the answer. So initially it will plan. After it plan, then it goes and starts to implement the plan. That is, check if there is any public ceremony. No. Check. Is it going to rain? Yes. Check if there is going to be anything else. Check. So all the planning items it would go through. So after the planning items are done, after the information is gathered, then it would come back to me and give me the response based on all these 5-6 factors. I can give you that this is how long it would take for me to reach my home or destination. The agent actually does that. And again, this is not LLM. This is purely a software engineering framework which is algorithmic driven, supported by a process which has been developed, supported or augmented with LLM. Now I can use the LLM to carry out, to figure out what my 10 plans are. Now to figure out all these 10 plans, I might need an LLM or I might need some other tools to actually do it. So I will develop that process or algorithm, and then towards the end, I need the response. So I will collect all the responses, give it back to LLM, which is a large language model, and ask it to finalize or condense or synthesize the information and give the responses back to me. So what the LLM can do, what the LLM cannot do is a clear-cut distinction that we need to know so that we can strategically leverage technologies, tools, and platforms like this to our advantage. All right. Now we will see what, like I said, there was one pattern here, which is a planner. Like that, what other patterns are there? I've given a list, but I'll just take one example to just give you a flavor of how it would look like. And agents are predominantly autonomous. So you don't really tell an agent what to do. Rather, it programmatically figures out what it has to do in an automated and an autonomous manner. Automation and autonomy goes together when you're operating with agents, and there are frameworks to do that, like how you have ChatGPT. there are also frameworks to perform or work with agents as well. I'm not introducing that to you. I'm just introducing a flavor of the concept of agent and how they work, so that at some point in time we can work on it. The four capabilities of agents: it reasons out. LLM, large language model, does not reason, but an agent can enable a large language model to reason. There is a difference. If you're asking a question, ChatGPT gives you an answer, that is not reasoning. Rather, you're creating an agent which, for my question, creates 10 different questions, sends it to ChatGPT, responses come in, it tries to revalidate the response, critically validate the responses generated by the large language model, send it back to the LLM, get the response, send it back, get the response. 5, 6, whatever number of iterations will happen, which is forcing or enforcing the large language model to consider a lot of things before responding. And that is what is basically called as reasoning here, and that is what an agent would do. An agent would sit outside the LLM and then interact with LLM with a lot of request and response communications happening. Whenever some response comes in, then try to finally provide us with the information that we are looking for. This is basically called as the reasoning part. And then comes the planning. We just discussed about what planning is. To answer a particular question, what are the different things I need to do to better respond to the user? That is basically what planning is. Decision making. Till what point or to what level the agent should interact with the LLM till the answer is convincing. Should it stop with 2 iterations or 5 iterations, 10 iterations? You don't influence it. Rather, the agent tries to be part of the decision making process until it is convinced that the response that we got from ChatGPT or any other LLM is good for the user and aligns with the user's expectation and interest. That is where the decision making comes in. And action taking. If at all you are programming the agent to do any actions, sending out emails, sending out some digital marketing content, or based on some evaluations that you have uploaded, if there is a portal that you connect where the agent can pass or fail the student based on the marks he scored, you can enable that agent to do that. And these are via a lot of plugins and integrations that you can work with, and that is what they also can possibly do for you, and that is what is called as action taking. So basically, reasoning, planning, decision making, and action taking are primary characteristics of a agent whenever you are building it. Okay, and there is a very popular pattern called as the React pattern. We will just spend the time on this and then go to ethics. I think we have 10-15 minutes more. What is the React pattern? React is reason plus act. We already saw reason here, and we already saw act here. These two things will not be done by an agent which has been designed using a React pattern. Only reason and action will directly happen. Now, how does that work? The most popular pattern for building AI agents that can think through the problem step by step. Real academic example, something can be like, help me prepare for a parent-teacher conference, something like that. So it will think, I need to understand what specific challenges this teacher is facing in the parent-teacher conference. Why is the teacher in the first place asking me for help in conducting a parent-teacher? And the action is search for teachers' documents from previous conference notes, if at all you have integrated it, and tries to understand if at all there are any struggles or feedbacks that it can either identify, or if we have given as part of our retrospective to improve something, right? And then it observes, okay, found 3 students struggling with math and behavior or whatever, and then it goes to the thinking process, action process, observation, thinking process, action process, observation. So this is how it goes to cycles, and at one point in time it decides, okay, this is the time, I don't have to iterate anymore, so I will now give the response to the user curated in a way that the question is asked, and also the references that I found, and also the other critical thinking process which I've iterated to get to this point. All this part is basically sorted out or solved using agent. Though generative AI and LLM became widely popular 2-3 years ago, now it is becoming more outdated, honestly. Today the entire globe is progressing towards agentic AI. Which is what we are saying. We have frameworks which leverages LLMs to create a framework or a pattern like this to be more automated and autonomous in whatever activities that we are asking it to do. And agentic AI is the way forward, and there are billions of dollars of investment that has already gone to it, and people wouldn't want to back away from it because they see potential. The investments have already gone into it, so the entire people like Microsoft, Google, Facebook, Meta will ensure that the whole world now follows them towards this. Even though there is a better idea, they would want the whole world to follow them, because now that the investment has gone in, now they'll have to seek the returns for it, right? So that is how the top brands or the top technology leaders invariably influence the larger community to follow something that they have fixed, and not really giving us the room or the freedom to have any alternative thoughts or any alternative paths, and they don't approve or accredit it. Because these bigger tech giants are associated with a lot of companies, right? Be it Fractal or TCS or Infosys. So when that tie-up is there, when that commercialization is already signed through, a common man like you and me will not have any say in that. We will have to follow what these people are asking us to follow invariably, and that is what would again now reflect in academics as well, right? So if there is a different wing of academics that is going to come in beyond agentic AI, beyond generative AI, it might come. There can be a brilliant idea, but that idea will just go off like a flame without oil. There will be no fueling. There will be no support. If wind comes, the thing will go. So you need to protect it. That entire ecosystem will not be there, basically. So that is the, in my view, that is the unfortunate state that we are all in. And at this point in time, I don't have an answer how this would solve or how it would evolve. But this is how things would move forward, whether we like it or not. And you can use these agents for research, teaching, assessment agents. You have all your answer sheets coming in. Can you create an agentic application to validate all the responses? You can definitely do, right? It can save you give a key to the agent, and you give all your answer sheets one after the other. The agent will be, and you upload it in the form of soft copies, so it will be able to extract all the information from the PDF, put it into a Word document, create a section for assessment and analysis. Question 1, mark 1, question 2, mark 2. It will be able to do all that based on the key that you have given, and 99.99% its evaluation will be correct, unless and until the handwriting is so poor that the agent itself is finding it hard to read or understand. Sometimes understanding the numbers, difference between 6, 8 and 9, people have different ways of writing. That still is a challenge, and that is where some human in the loop process is required, where after evaluation like this, we step in and then try to, instead of spending 10 minutes, we might spend 2 to 3 minutes to browse through all these answers, and to a larger extent we can justify the effort that is going into it. That is how you can enable such a technology like this to do the heavy lifting for the day-to-day monotonous routine activities that you do, and you take that 1 hour 2 hour in a day to effectively utilize on other areas of interest or convenience for you to have a more scope wherever you work, rather than getting bogged down by too much of roles and responsibilities and activities like this, which otherwise could have been easily delegated or done by someone, given that some guidelines are given, right? Whatever, that handoff can be effectively carried out when you are inheriting a technology or adopting a technology like this. Okay, so agent basically does that, and I think these references basically more like an if then statement, decision making processing, if then why else, etc., etc. Like if a student, like if student attendance is greater than 90 and assignment completion is greater than 80 but exam scores less than 70, then focus on study skills and exam preparation strategies. If attendance less than 70 and assignment completion is also less, address engagement and motivation itself is not there, because his attendance and engagement has come down. So these are basically rules that you can create for the agent to follow based on your initial analysis, and it will then give you recommendations based on the heuristics of the rules that you are feeding into it, right? So limitations, considerations, again I think I'll leave it for your reading. I'll move on to the last part, which is AI ethics, or just I'll take 2 minutes on prompt engineering and then go to AI ethics. So whenever you're taking a prompt, right? Right now, prompt engineering. I'll just give you the insight. Okay. Uh, Today, what people might say is when you are asking questions to ChatGPT, you should know prompt engineering so that you can effectively converse with it, right? And there are different techniques to be used. Actual prompt engineering is not that. So, prompt engineering is used by the creators of applications like this. For example, people from OpenAI who built ChatGPT use prompt engineering. And prompt engineering is not 4 or 5 lines that we type as a question to the chatbot. Prompt engineering will be 500 lines, 600 lines, 1,000 lines of text with different templates and etc sitting in the bucket. Remember the template that I was saying where you have an input, your context. Yeah. Similarly, there will be a template sitting behind the application. That is where prompt engineers would come in. And today's prompt engineers in the West are getting paid easily around somewhere between 150K USD to 300K USD, like almost like one crore, something like that in their currency. Purchase power parity, if you take for Indian currency, you cannot directly convert. There's a purchase power parity calculation. It comes to at least 30 to 40, 50 lakhs for Indian currency. But the point is that prompt engineering is very heavy stuff. To actually do prompt engineering in a very traditional manner, you should know computational linguistics. That is the field of study wherein first you master the language, like you become very proficient with English, like doing an MA, whatever, and then you associate mathematical models to better represent the language for computation purpose, and that is what computational linguistics is all about. And these are the researchers whom companies like Claude, OpenAI, etc hire, and then they create that prompt template, and that prompt template is what it gets served or served for millions of users who are actually using the application. So that is where true, real, high-tech prompt engineering happens. Now, as a user, people are asking us to do prompt engineering to answer what does that mean, etc. Don't overcomplicate it, right? Whenever you are asking a question, if you are good in asking questions, if you are good in giving instructions in real life, using ChatGPT, knowing prompt engineering, you don't need. If you, for example, if there is something that you want someone to do, right, and different people have different way of giving instructions. Someone would really get into the details, someone would just give at a high level and hope that that person would figure it out and do it, etc, right? It's an art. Not everyone masters, right? And if you're asking questions